Hello guys, and this video is over circulation. Circulation is basically another way of just trying to figure out work per se. I wouldn't say it's equivalent to work, but you find it in the same fashion. It's all dependent upon what you consider F. F can be a force, vector, force field. It can be anything. What we mean by work, we typically mean just a force and the terms of physics, like from 298 and along its pathway. But remember, it's the integral of f dot dr, where f is equal to m mi plus nj plus pk, where dr, when dotted with f, would leave you with m dx plus n dy plus p dz. But we're only dealing with 2D. We're dealing in the y and x for right now for units. So we really only care about this. We'll say this equation: m dx plus n dy. And this is essentially the same kind of workaround for force. So in order to calculate this, we have to figure out the force across each part of your pathway, and pathway is really important because depending on which direction you go will change the outcome of your value. If we go, this is kind of like from the limits in the first unit. Depending upon which pathway you went, you might get 4 or 10 or negative 20 if it depended upon if you went y equals x, y equals 1 minus x squared, x equals the square root of y, different things. So this is where that pathway really does matter in terms of more than just what value you get from a limit. It's now what outcome do you get from your force input. So in order to figure out this circulation, you have to look at the pathway, meaning that little circle there of where you go. And in this case, it typically doesn't matter if you go one direction or the other for circulation. It matters for flux, because flux is dependent upon a vector normal to that pathway. But for circulation, it's all dependent upon just the actual where you go. Doesn't matter if you go forwards or backwards. But typically they'll go counterclockwise. So this one will be going counterclockwise. I'd say it can't go clockwise, but it will typically go counterclockwise, especially if that's what the direction you choose on your integral. Normally they might just draw it like this with a little circle, because they don't want to, to them it doesn't really matter that much. They don't try to lead you on that much part of the problem, unless they're dealing with flux. For circulation, again, they don't really care about, but for flux, they care about direction. Now to find circulation, again, we have to look at the integral of m dx plus n dy for each of the C1 and C2. So first we're going to do C1. So this is along C1. So this will equal the integral from 0 to 1. Or sorry, 0, 0, 1, 0. And we're looking at this in terms of x and y. And you can do this in different ways. But when we do the m dx plus n dy, we're going to get y dx plus, apologies, it's going to be a minus because I have a minus sign here, x squared plus y dy. If we had everything in terms of x here and everything in terms of y here, we could just integrate like that and it'd be all fine. But since there's a mix match, then we need to solve for each part in terms of one variable or the other. So if we have, we're going along the pathway y equals 0 here, then we know that y will equal 0. When we set it for y equals 0, then we're just left with minus x squared dy. Alright. So, do we know dy? We do. We can figure it out at least. So what you have to do is look at y. So y equal to 0, and then to take derivative of that, so dy dx equals 0 as well. Move the dx over, and we have dy equal to 0 dx, which is essentially 0. So this right here is 0 as well. So this term went to 0, this term went to 0, and then now this term's going to go to 0, which means we're just taking the integral from 0, 0 to negative 1 to 1, 0 of 0, and we don't have a dx or a dy. So this will just essentially just equal 0. So that's the pathway for C1. Now for C2, I'm going to change up the color here. For C2, however, it'll be a little different. So for C2, again, we'll have mdx plus ndy. So m being, again, we'll have the same starting point, except for our points will be a little, like these equations right here will be the same, except for our limits will be different. So we're going from 1, 0 to 0, 1 of y dx minus x squared plus y dy. So now here we have y equal to 1 minus x squared. So if y equals 1 minus x squared, we can plug that straight in for this y and this y, and then we'll have almost everything in terms of x. So I'm going to go ahead. So it means we're going 4 in terms of x, so we can just say this is just going to end up being an integral only looking at the x value. So we're going from 1 to 0, because those are the x values here, because we're going to try to do this all in terms of x. So we have 1 minus x squared dx minus x squared plus 1 minus x squared, then dy. So what is this dy? Again, it's the same thing we did over here. We say dy dx is equal to the derivative, which is negative 2x, and then dy will equal negative 2x dx. All we did there was just multiply the dx over. So that's what this dy here equals. So I'm just going to erase this dy. So it's minus 2x dx. Simplify this all down. So we go from 1 to 0 of 1 minus x squared. This right here, x's cancel out. So we have minus 1 again times 2x. So it comes plus 2x. And all times by dx. So now I'm going to integrate. So we'll have negative x cubed over 3 plus x squared plus x. This is a value from 0 to 1. Sorry, from 1 to 0, which then equals 0 minus negative 1/3 plus 1 plus 1, which then equals negative, so this becomes minus 1 over 3 plus 3 over 3 plus 3 over 3. We're going to say 6 over 3 to save on space. So we get a 5 over 3, then times that by a negative, which equals negative 5 over 3. And then we need to find the integral for all of c, which equals the integral for c1 plus c2. So just to reiterate, you don't put the little symbol on c1 or c2 because it's not the entire pathway. It's part of a pathway. It's a singular path. But we're adding the pathways together to get the total pathway, which is why now we have the total c, which then is equals 0 plus negative 5/3, which equals negative 5/3. All right, I hope this helps. If you have any questions or see anything you're unsure about, please comment or email me. Good luck on your tests.